Welcome to Calculus. We're going to do a couple of extra examples from 4.6, really one example, but we're going to do it with both the trapezoid rule and Simpsons rule. And we're going to find the area under this curve, y equals e to the x, or f of x, let's call it f of x, equals e to the x. We haven't done a lot with e to the x. We definitely don't know how to integrate it yet, but we'll learn it next chapter, and it's actually quite easy. But until then, we're going to do a couple of approximation techniques. So let's find the area under the curve from 0 to 4. So the way you'd set that up, one way, it'd be nice if you could do this, right? But we don't know how to integrate this yet. So let's do an approximation. Let's start with trapezoid rule. So I will the area under the figure, say sub t for trapezoid. Remember our formula. So the first thing we want to do is calculate delta x, and that is b minus a, which is 4 minus 0 over n. So that's going to be 4 over n here. Then also, remember trapezoid rule has an extra 2 down there. Oh, I should have told you. Let's break this into 4 regions. So we don't need an n, that would be odd. So we can now put 4 down there. And I picked some nice numbers, as you can see, because this just becomes 1. So delta x is 1, and then it's also over 2. Just the formula you might recall for is delta x over 2, and then you have the f at a plus blah blah blah, blah, so on. So our f at a will be the function evaluated at 0 plus 2 times evaluated at 1 plus 2 times evaluated at 2, and you just keep adding 1 until you get to the right endpoint. Oh, I made a mistake. I'll fix it in a second. Should have had a 2 there, right? So all the middle terms have 2. This guy, and this guy have 2 as a coefficient, and the ones on the end only have 1. And we talked about why that is, because the end ones are only involved in one trapezoid, and they're the trapezoids there, and the middle ones are part of 2 trapezoids, so we count those twice. Okay, so then you just want to simplify this out, and I picked a really nice one for you. E to the 0, keep forgetting that, 2 times e to the first, plus 2 times e squared, plus 2 times e cubed, plus 2e to the fourth, not 2e to the fourth, plus e to the fourth, and let's see, I got the same number of terms, I got 3 2's, looks good, and this turns out to be 57.99 is our approximation. So we'll try to remember that. So that's using the trapezoid rule, which works pretty well. And you can see what I want you to show on this. I mean, you write down your problem. That is the problem with the number of rectangles. Show your setup with the f's. So your setup with plugged in the function and your decimal approximation. So it's really pretty short. Let's try it with trapezoid rule now. Oh, I'm sorry, with Simpsons rule now. So Simpsons rule, I'll quickly review the formula, is delta x over 3 times the function evaluated at the left endpoint plus 4 times the function evaluated at the left endpoint plus delta x plus 2 times the function evaluated at the left endpoint plus 2 delta x's plus 4 times the function evaluated at the left endpoint plus 3 delta x's, and it bounces back and forth from 2 to 4 as long as you want to go. But one interesting thing is the second to last will always be a 4. Oops. And the only way that can happen is if you have an even number of, where n is even. And so n has to be even. I'm going to ask you to make it even like we did 4 on this one. So we'll do that again. Let's just call this b minus delta x plus f at b. Okay, there's the formula. Okay, so for us, area using Simpsons Rule is going to be delta x. Let's see, what was it? 1, right? 1 over 3, because the 3 there. F at a, e to the 0, plus 4e to the first, plus 2e squared, plus 4e cubed, plus e to the fourth. And when you look at your other, compare this, what I just put in my calculator, it's the same thing except for three differences. This is 1/3, this is a 4, and this is a 4. So if you put it all in your calculator in one move, which I did, then this is going to be quite easy to change. I'm just going to second enter, or you can arrow up if you're one of those people. And I'm going to put a 1/3 there. I might give myself a little more space here. 1/3. And then I just change that to a 4, and I change the other one to a 4. And let's see what we end up with. Oh, I made a mistake. Let's try that again. 1/3. Okay, I'm back. Never do calculations like that live. I probably should have done that off air. I'm back. I got it to work. Just a little calculator mistype there. And it turns out to be pretty similar to the other one. This one turns out to be 53.86. And recall, the trapezoid one was 57.99. Pretty different. So which one's right? Well, I happen to know the answer is, oh, here I go again doing it, is the true answer is 54.60. So it seems that Simpsons is better, and that's not just this case. That is typically true. I think maybe always true. Considerably better, really. So there you go. There's the two techniques. That's all you really need to write. I didn't on this one. I should have. I didn't put the form with the F, and I told you I wanted you to do that. So let's add that on there. Sorry about that. So let's just erase all this. So I would like you to do this still. I want f at 0 plus 4f at 1. Right, yeah, plus 2f at 2 plus 4f at 3 plus f at 4. So I'm going to ask you to do that still. So again, the required steps to review are this step with the f's, the step where you evaluate the function, and your approximation would be what I'd like you to show. I want to show you one last thing in our final moments here, and you'll want to stick around for this. This is going to be how we can, if you haven't figured this out already, I do want to bring all of you in on how to do these definite integrals in our calculator. So this is the way you can check your work. If you're the parts of the test where you can use your calculator, you certainly can do this to check your work. Really, it's something we can do all year to check ourselves, but in truth, we'll do more the indefinite type than the definite. But let's do that on the next page. Okay, on your calculator, there's two ways to do this. The first way is more the wow way. It's cool, but the second way probably is more, it's quicker and more practical. So, first of all, go to y equals in your calculator and put in there e to the x. So I'll do that on mine, e to the x, graph it. So again, this was, I did y equals first, y equals, then I'm going to graph, and depending on your window, I'm just going to go back and do zoom 6 so I can see this. Okay. Then you're going to go second calc, or second trace, just like we've done many times, and you scroll down, you see things like 0, minimum, maximum, intersection. We've done those before. But look at the 7th one down. I think it's 7th. It's at least on my old calculator I'm using right now. 7th or 8th. You see an integral. Hit that, and it says lower limit question mark. So I guess I should put on here, I did second calc. And then I'm going to, after that, I did the integral, which mine looks like that, and then asked me lower limit. then I'm going to put 0, because remember I'm going to go from 0 to 7, so I think you can just type in 0, okay, and then I'm going to type, oh, my calculator's really old here, then I'm going to type 4, what's that for upper limit, I think it said, and I'm going to type, you're probably ahead of me by now, upper limit, type 4, hit enter, and you see a real nice shading going on, and at the bottom of the screen it gives you the true answer. Pretty awesome. Okay, second technique. This one's probably easier. You don't have the wow factor of the graph, but I think it's a little bit faster. So go to the main screen, second quit, and you can hit math button. So let me write that out, math. And if you scroll down, you're going to see I think on mine it's the 9th, but it looks like this, FNINT. It means function integrate. And for most of you, you're going to be shocked when you hit enter that this awesome little thing is going to pop up like this. And this is pretty self-explanatory, I think, what to do, right? This is going to be, let's get a different color. This is going to be your upper bound. I'm going to call it UL for upper limit. Your lower limit, you plug that in there. This will be X for, unless you want to put a different letter, and then here's where you put your formula. So you can put in your 4 and your 0 and your X there, and here put E to the X, and it will get your answer. What did I say it was? 54.60598, something like that. So you can use that from now on to check your work. And the book does actually mention that. Use a graphing utility to check your work, or something like that. So feel free to do that, and hope that was helpful. See you next time.